Curvilinear coordinate systems 13, a hyperbolic UVZ coordinate system is sometimes used in electrostatics and hydrodynamics. These coordinates are related to the standard Cartesian coordinates by the following equations: u equals 2xy, v equals x squared minus y squared, and z equals c. So part A asked us to sketch the lines of constant u and v, and we have done that in part A, and this is basically what we obtain. And then we have shown the unit vectors EU hat and EV hat on this coordinate system. We have shown that this is a left-handed coordinate system in part C, and to make it right-handed, we switch the positions of U and V. And then in part D, in the right-handed version of the system, we were asked to obtain the scale factors. So here we have the position vector x ex hat, y ey hat, and z ez hat, where x, y, and z were written in terms of u, v, and z. And we have obtained this position vector, and from that we obtained the scale factors. Now in part E, express the position and displacement vectors in this coordinate system. Now for that, here is the position vector we have obtained in part D using x ex hat, y ey hat, and z ez hat with the coordinate transformation equations. Now we're going to obtain the unit vector EU hat let's obtain the unit vector EU hat, which is 1 over the scale factor h sub u del r del u. All right, and now I have to copy 1 over the scale factor here. Scale factor is u squared plus v squared to the power minus 1 over 4 over 2. So if I take the reciprocal, it's going to be 2 times u squared plus v squared to the power 1 over 4. Then I can start taking the derivative of this with respect to u. So let's work with the positive version here. So we're going to have, first of all, a 1 over 2 factor up front. So there's going to be a 1 over 2. And then we have the parentheses u plus square root of u squared plus v squared divided by 2. This is now raised to the power minus 1 over 2. Then we have to go inside to take the derivative. And so you can see that when I take the derivative here, I'm going to get from inside a 1 over 2 factor from this one, a 1 over 2 factor from this one. So let's take the 1 over 2 out. And then I have from the derivative of u, 1. From the derivative of square root u squared plus v squared, I will obtain a 2u, and then from the square root I will obtain a 1 over 2 factor, so it's going to be just u, and u squared plus v squared to the power minus 1 over 2, and this will be in ex hat direction. Now I can take similarly the derivative for y. This is going to give us, again, 1 over the scale factor. HU and HV were the same, remember. This is 2 parentheses u squared plus v squared to the power 1 over 4. Again, I have 1 over 2. This time, inside the parentheses, I have minus u plus square root of u square plus v square divided by 2 to the power minus 1 over 2. Then again I have the 1 over 2 factor when taking the derivative of this inside the parentheses. And this time instead of plus u I have minus u, so the derivative gives me minus 1. And then I have plus u square plus v square to the power minus 1 over 2. This will be in EY hat direction. All right. So basically, I was able to write the unit vector EU hat. Now let's take a look at some simplifications here. This 1 over 2 cancels with this 2. And so this 1 over 2 will go up front. I can write my unit vector EU hat as u square plus v square to the power 1 over 4 divided by 2. Then I have u plus square root of u square plus v square divided by 2 to the power minus 1 over 2. Then I have 1 plus u square plus v square to the power minus 1 over 2 in EX hat direction. Then I add to this u square plus v square to the power 1 over 4 divided by 2 minus u plus square root of u square plus v square divided by 2 to the power minus 1/2, and then minus 1 plus u square plus v square to the power minus 1 over 2 in EY hat direction. And there is no u derivative of z, so we don't have that. Now if I take the dot product of the position vector with EU hat, I will find the projection onto EU hat direction. All right, and now if I look at my x component here, so I have to multiply this with the x component that I see here and multiply that with the y component that I see here and add them up. Okay, so I have u square plus v square to the power 1 over 4 divided by 2. Now if I multiply this with that, you can see that these two terms will cancel out. It's going to be 1. So this will be 1 plus u square plus v square to the power minus 1 over 2. And when I do the same thing for the y hat component, again I will have this one cancelling with the to the power minus 1/2, and with this common parentheses here I'm going to get minus 1 plus u parentheses u square plus v square to the power minus 1 over 2. And I have plus 1 and minus 1 cancelling, and this gives me 2u. So there's this 2u, these two terms are the same. Now I have u squared plus v squared to the power minus 1/2 and plus 1 over 4. So plus 1 over 4 minus 2 over 4 will give me minus 1 over 4. So this will be 2u over 2 u squared plus v squared to the power minus 1 over 4. Therefore, my u hat component is u divided by u squared plus v squared to the power 1 over 4. Now, if I try to calculate the unit vector EV hat, similarly, I have to do 1 over the scale factor h sub v del r del v. And here is 1 over the scale factor h sub v. It will be two times u squared plus v squared to the power 1 over 4. Similar to the previous case I had here. Now I can start taking the derivative of this. So I'm going to get a 1 over 2, this to the power minus 1/2. So here is my 1 over 2. So I'm taking the derivative with respect to b of this term now. So there's 1 over 2 u plus square root of u squared plus v squared divided by 2 to the power minus 1/2. Then I take the derivative of the inside the parentheses. I have 1 over 2. Then there is the 2v and u squared plus v squared to the power minus 1 over 2. And this will be in ex hat direction. So these 2's will cancel, and also I will have a cancellation of these two 2's in this case. And for the y hat component, again, I have plus 2 u squared plus v squared to the power 1 over 4. This time I have 1 over 2 minus u plus square root of u squared plus v squared divided by 2 to the power minus 1 over 2. Then I have the same term, 1 over 2, 2v u squared plus v squared to the power minus 1 over 2 in ey hat direction. All right. And again, I have the cancellation of these twos and these twos. And when I take the dot product r dot ev hat, I will find this component being multiplied by this, giving me a cancellation. So it's going to be a u squared plus v squared to the power 1 over 4. And then I have v times u squared plus v squared to the power minus 1 over 2. And the same thing will happen for the y component here. So this is going to cancel out with this. So I'm going to get this same thing twice here. Therefore, I have a factor of 2. So this gives me the final result for r dot ev hat to be 2v divided by r squared plus v squared to the power 1 over 4, and r dot ez hat is equal to z. Now I'm ready to write the position vector in this new coordinate system. So we can write r is equal to u over u squared plus v squared to the power 1 over 4 in EU hat direction. That's because r dot EU hat was calculated here. And then we have r dot EV hat, which gave us this result. So then we have plus 2v over u squared plus v squared to the power 1 over 4 EV hat plus z ez hat. This is our position vector written in the new coordinate system. Now we can write the displacement vector dr. That's del r del u du plus del r del v dv plus del r del z dz, and this is basically hu du in EU hat direction. This is hv dv in EV hat direction, and this is hz dz in ez hat direction. So we can substitute our hu 1 over 2 u squared plus v squared to the power minus 1 over 4 du in EU hat direction. Then I have 1 over 2 u squared plus v squared to the power minus 1 over 4 dv in EV hat direction, and I have dz in ez hat direction. This is our displacement vector. All right, so we were asked to write the position vector in the new coordinate system, UVZ coordinate system. So we have the position vector r here, and for each of the unit vectors EU hat, I have to calculate 1 over hu, which is 2 u squared plus v squared to the power 1/4 del R del U, and for EV hat 1 over HV, the same thing, del R del V. Now, when I take the derivative del R del U, this 1/2 comes up front, the parenthesis to the power minus 1/2, then the derivative of inside, so it's going to be 1 over 2, 1 plus 2u over 2, because of the square root here, it's going to be u squared plus v squared to the power minus 1/2 for the x component. For the y component, we just have, instead of 1, a minus 1. And this gave us our final unit vector EU hat, u squared plus v squared to the power 1 over 4 divided by 2. This first term here to the power minus 1/2, and then we have 1 plus u squared plus v squared to minus 1/2. This is in EX hat direction, and the other one has the minus u version. When I take the dot product r dot EU hat, the x components, you can see that I'm multiplying this with that. That's going to give me a 1. So I will have, in this parenthesis, this term added to this term. So that's going to give me 2u u squared plus v squared to the power minus 1 over 2. There is a 2 there, so 2's cancel. And I'm going to have u squared plus v squared to the power minus 1 over 4 times u. And for EV hat, I have to take a derivative with respect to v now. So for the x hat component, so I'm going to have again the same thing, 1 over 2, this raised to the power minus 1/2, and this time, when taking the v derivative, this has no contribution, so I will have 1/2 2v u squared plus v squared to the power minus 1/2. And the same thing will happen for the y term, but this time I have minus u. Minus u or plus u doesn't change the result because I have no v dependence there in taking the derivative. All right, and when I take the dot product of this with the position vector r, this term and this term will disappear. So I will have u squared plus v squared to the power 1 over 4 parentheses. The same thing, basically v u squared plus v squared to minus 1/2. So this is going to be twice. So I will have 2v r u squared plus v squared u squared plus v squared to the power 1 over 4. So that's r dot ev hat. So knowing r dot eu hat and r dot ev hat, I can write my position vector. Now the displacement vectors del r del u du, del r del v dv, and del r del z dz, which is hu du eu hat, hv dv ev hat, and hc dz ez hat.